the gang is back with fun-filled laughs, giggles, and a brand new DVD. Science Show by the geniuses of Sit 21.
Critics say it's even better than Bill Nye.
Coming out fall of 2015. Coming out now.
I'm here today to talk to you about the composition of the atmosphere. The atmosphere has countless elements, but the most common element is nitrogen. It has a whopping 78% of the atmosphere. Most of the newbies think that oxygen is the most common gas, but no, it is 21% of the atmosphere. The other 1% is made of hydrogen, carbon, and lots of other gases. Carbon dioxide is one of the most important out of all those gases, because you'll learn about that, why it's so important later. Stop it. The atmosphere is very important to us. It protects us from the UV rays of the sun. They already harm us a little bit, but without the atmosphere, we would be like burnt toast. Also, the atmosphere allows water to exist on Earth. As we all know, water allows for us to live. Next, air pollution is hurting our atmosphere. The atmosphere is like a shield from the sun's UV rays, and without it, we would all die. This is why air pollution could hurt our atmosphere, and it could also hurt us. There is lots of air pressure in the air. Air pressure is measured by a barometer. You have lots of these on the rocket ship, so you know how high or low the air pressure is. The higher you go, the lower the air pressure gets. That means that when you're in space, you'll experience very low air pressure. The next segment is going to be about the layers of the atmosphere with Isaac.
Have you ever wondered why water stays on our planet? Well, it's because of the atmosphere. And the atmosphere has 4 layers. The troposphere is the first layer. It keeps us on Earth, and this is where we live. It has weather, and as we go up, the temperature decreases, and it's only about 10 kilometers high. But as we go further into the stratosphere, the temperature grows higher as we rise, and it's only about 50 kilometers away from our surface. And what happens is that there's the jet stream there, and we have the ozone layer. And the ozone, it helps us basically survive from UV radiation, or we'll be bacon right now. And the jet stream is basically like a thick stream of, it's like a... And now is the mesosphere. Do you know why the meteors usually don't really come here? It's because they're really small and they burn up here. And as we rise in the mesosphere, as you know again, the temperature decreases. The mesosphere is also 100 minus 20 kilometers, which is 80 kilometers. The thermosphere is divided into 2 parts, the ionosphere and exosphere. As you rise up, the temperature rises, but the ions are too spread out, so we can't even actually feel it that's warm. So, the ionosphere has ions, basically, and it contains the northern lights, or the aurora lights. And the exosphere, well, we just use our satellites there. This has been Layers of the Atmosphere. Now on to Jack.
Thermal energy, more commonly known as heat. Sorry you had to see that. Anyways, thermal energy is heat. There are 3 ways for heat to be expressed. Conduction is when heat is transferred through a solid, like when you're holding a pan and it burns you. Here is our super pan of science. As it heats up, the heat goes through the atoms of the pan, eventually burning me. We also have convection. This is when heat is transferred through liquids and gases. It makes an up and down motion, creating convection currents. So we have ocean currents and wind! And one is radiation, when heat travels through pure nothingness or a vacuum. An example of this is the sun's rays traveling through space.
There is something that traps heat in the air. It is called the greenhouse effect.
This is when heat comes in and doesn't go out, like a greenhouse in its plants. Carbon dioxide, or CO2, is the most abundant greenhouse gas in the atmosphere. It absorbs infrared radiation, and the molecules start vibrating, while heat is spread all across the atmosphere. Wait, hey, that was my line. This has been thermal energy. Put your hands together for Anya Bowers.
Anya Bowers from the SIT21 science team, here to talk to you about wind. What do you think when you hear that word, wind? Well, you may not know this, but there are actually two types of wind, local and global. Global is the wind that occurs across continents due to the Coriolis effect. These winds blow steadily from the same direction and all the time. The three types of global winds are polar easterlies, westerlies, and trade winds. Jet stream is also very important with wind. It causes the U.S. weather to blow east to west. Jet stream can go as fast as 400 kilometers per hour. It goes all the way around the Earth and is measured by an anemometer. Here is our anemometer of science. The wind blows into the cups and spins it. You measure it by one of the cups, by how many times it goes around. I hope you enjoyed our video. See you later.
This has been the SIT21 Science Show. Thanks for watching. And remember, come back soon.